After discussing triangle incongruencies for over a week, we're now moving on to parallelograms and rectangles. Parallelograms and rectangles can be broken into triangles, so they naturally are going to follow the triangle congruencies. Because of those triangle congruencies, several properties of parallelograms and rectangles exist. And these are just two of the quadrilaterals, and we'll talk more about different quadrilaterals in another unit, but we're looking at some very specific properties that we're going to prove using the triangle congruencies. So what is a parallelogram? So by definition, a parallelogram is a quadrilateral with both pair of opposite sides parallel. So you can see in this picture that we know that AB and CD are parallel because they have that same mark. And likewise, BC and AD are parallel. Okay, so that is the definition of a parallelogram. Quadrilateral, which means four sides, opposite sides are parallel. Now, as a result, there are several properties of parallelograms. Four main ones. Okay? One is that opposite sides are going to be congruent. So in the picture, JM and KL are congruent. In segment, JK and ML are congruent. Parallelograms also have opposite angles that are congruent. So angle J and angle L are congruent, and likewise angle K and angle M are congruent. The next property for parallelograms are that consecutive angles are supplementary. Consecutive angles are the angles next to each other. So these aren't labeled, but I can label them real quick. A, B, C, D. Angle A and angle B are consecutive angles. Or angle B and angle C are consecutive angles. Angle C and angle D are consecutive angles. And A and D are also consecutive angles. If you remember from when we talked about parallel lines, we had same side interior angles, also known as consecutive interior angles. That's what those are. And that's why they're supplementary, is because the lines are parallel. So if the lines are parallel, then those consecutive angles have to be supplementary. The final property of a parallelogram is that the diagonals bisect each other. So what that means is when you draw the diagonals, those are the lines that go to opposite corners of your parallelogram. So AC to BD. AC is one diagonal and BD is your other diagonal. They actually cut each other in half. So they meet or they intersect at the midpoint. And so if I called that point M, then AM and MC are going to be congruent, and likewise DM and BM would be congruent. So those diagonals cut each other in half or they bisect each other. So we're going to use all those properties and we're going to find some stuff out about some parallelograms. So for our first example, we are told that XY equals 15. So that's right here. We're told that WX equals 22. We're told that ZX, which is that long diagonal, is 52. I can't really label that, but I'll deal with that in just a second. And then WT is 23. So we're just going to focus on the segments first, and then we'll look at angles. So let's start with the outside of the parallelogram. So one of the properties is that opposite sides are congruent. So if XY is 15, then WZ would be 15, or ZW, however you want to name it. And if WX is 22, then ZY will also be 22. So that's just the outside. Now on the inside, as far as the diagonals are concerned, we're told that the diagonals bisect each other, so they cut each other in half. So T is actually the midpoint of WY, which makes TY also 23. And then we were told that XZ, or ZX, was 52. So that's the whole length. If we cut that in half, 52 divided by 2 is going to be 26. So that means that ZT is 26, and so is TX. So we're asked for TX, so that would be 26. And they also ask us for WY, which is the length of the entire diagonal, because each piece is 23, then 23 plus 23 would be 46. So that's how you find all of the segments within a parallelogram. So I'm going to erase all of those numbers so that we can free up a little bit of room so that we can look at the angles now. All right, so what angles did they give us? They told us that W, Z, Y, so that's this whole angle right here, is 72 degrees. I'm actually going to put that on the outside of the angle. 72 degrees. We're also told that WXT, so that's part of this little angle right here, is 35 degrees. And we're told that ZWT, so that's this angle right here, is 59 degrees. All right, so here's what we do know. In a rectangle, we know that opposite angles are congruent. So WZY, which is 72 degrees, will equal WXY, which we have part of that angle is 35 degrees. So if we do 72 minus 35 degrees, we will get the measure of angle YXT. So this angle right here is going to be 72 minus 35, which would give us 37 degrees. Okay. And so then we can translate those two angles because of alternate interior angles. We know that YZT is going to be 35 degrees. And we know that WZT is going to be 37 degrees. Okay. All right, we know that ZWY is 59 degrees. And because of the lines being parallel and alternate interior angles, we can also conclude that angle XYW will also be 59 degrees. So how do we find the other missing angles? Well, there's a couple different ways to do it. So one of the other properties of parallelogram is not only are opposite angles congruent, but consecutive angles are supplementary. So angle, let me just draw this out so you can see it a little better. I'm going to draw it without the diagonals. Z, W, X, and then Y. If angle Z is 72 degrees, angle X is 72 degrees because they're opposite angles. But W and Y are going to be supplementary to X and Z. So W and Z together have to be 180. So if I do 180 minus 72, I'm going to get that angle W is 108, and so is angle Y. Okay, and again, that came from that these two angles have to be supplementary. W and Z have to be supplementary. So 180 minus 72. So if I know that that whole angle W is 108, to find that missing part of that angle, if I do 108 minus 59, that's going to give me 49 degrees. And likewise, so that's for XWY, ZYW will also be 49 degrees. And then if I need to find any of those inside angles that come from T, I can use the triangle sum theorem. But let's go ahead and see if we need to find those before we do find them, just so we don't find anything extra. So looking at what they ask us to find, they ask us to find TZY. So TZY would be starting at T, going to Z, and going to the Y. So we have 35 degrees. Next up, we have XWT. So start at X, go to W, go to T. We have that angle in there is 49 degrees. Now we're going from X to Y to T. X, Y to T. That's 59 degrees. And finally, what color do we want to use? We'll do light green. we are going from X to Y to Z. So that's that big full angle, and that was 108 degrees. And again, if we needed to find any of these interior angles that are coming off of T, we could have used the triangle sum theorem, because we know that the three angles in a triangle do have to add to equal 180 degrees. All right, let's look at a couple more examples that are a little bit more specific, and you're not trying to find everything, because I know that can be kind of confusing. So here we're trying to find the measure of angle R. That's what we're looking for. If I knew the measure of angle P or the measure of angle Q, then I could find R. And I don't have their measures yet, but I can find them. So P and Q are consecutive angles, and we know that consecutive angles should be supplementary because the lines are parallel. So what I'm going to do is I'm going to add 8x minus 12 to 3x plus 5, and I'm going to set that equal to 180. Again, consecutive angles are supplementary. So if I add 8x and 3x, that's going to give me 11x. If I combine negative 12 and positive 5, that's going to give me negative 7. And that is going to equal 180. I'm then going to add 7 to both sides. So that gives me 11x equals 187. And then I'm going to divide both sides by 11, giving me x equals 17. Now be careful, the question doesn't ask us to find x. It could have, but it didn't. It asked us to find r. I know that r has the same measure as p because those are opposite angles, and in the parallelogram, opposite angles are congruent. So if I want to find angle r, I just need to find angle p. So I'm going to take the 17 that I just got, and I'm going to substitute it back in for x, in for angle p. So 3 times 17 is 51, and 51 plus 5 is 56. So that's for the measure of angle p. So the measure of angle r will also be 56 degrees because opposite angles are congruent. I could have also substituted 17 in for x on Q and found angle Q, and then taken that measure and subtracted it from 180, and that would have given me 56 for angle R. For our last parallelogram problem, we know that TV is 74, so that's that whole length of that segment, and we know that WV is 4x plus 1. So I'm just going to kind of draw TV, and then here's W. So I know WV is 4x plus 1. What we do know about that diagonal is that diagonals bisect each other. So TW and WV actually have the same measure. So if WV is 4x plus 1, then so is TW. And we know that the whole thing together is 74 degrees. So what I'm going to do is I'm going to add those two pieces together and set them equal to 74. So 4x plus 1 plus 4x plus 1, or you could have just multiplied by 2, equals 74. You could have also taken half of 74, which is 37, and then just set one of them equal to 37. There's a couple different ways you can do that. So I'm going to combine my like terms. I have 4x and 4x, which is 8x. And then I have 1 and 1, which is 2. And that equals 74. So now to solve, I'm going to subtract 2 from both sides. So that gives me 8x equals 72. I'm going to divide both sides by 8, and I'm going to get x equals 9. I'm going to go back and read the problem. It says solve for x, so I have found what I needed to find. If you want to check it, you can definitely plug 9 back in for your x. So 4 times 9 is 36 plus 1, so that would give me 37 for both of those, and 37 plus 37 is 74, so it's kind of a good check just to make sure that you're doing it correctly. So again, just to recap parallelograms, their definition is that opposite sides are parallel. and then they have 4 properties. Their opposite sides are congruent, their opposite angles are congruent, their consecutive angles are supplementary, and their diagonals bisect each other. So now we're going to extend that and we're going to talk a little bit more about rectangles. By definition, a rectangle is a parallelogram that has 4 congruent right angles. Okay, so the definition is that it has 4 right angles. So all 4 angles measure 90 degrees. But because it is a parallelogram, all of those characteristics that are true for parallelograms will also be true for rectangles. So those 5 characteristics that we just went over: opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and diagonals bisect each other. Those 5 things are all true for a rectangle. But a rectangle is unique because it has those 4 right angles, or 4 90-degree angles, and the diagonals, not only do they bisect each other, but the diagonals are congruent. So actually all 4 pieces have the same length. So this piece, this piece, this piece, this piece, all 4 of them have the same length. So that is something that's unique to rectangles. That is not true for parallelograms. So for our first rectangle problem, we're going to find a lot of different sides and a lot of different angles. Let's go ahead and start with the sides. We're told that DB, which is the diagonal, is 42. Now what we know is that the other diagonal, AC, is congruent, so we would know that AC is 42. We also know that the diagonals bisect each other. So that means that AE is congruent to CE, and BE and DE are also congruent. So if they bisect each other, that means they cut each other in half, and so if they're 42 in length, then cut in half would be 21. So all of these little guys are 21 inside. So we are asked for EB, which would be 21. All right, we are also told that AD is 26, and if AD is 26, opposite sides are congruent, so BC is also 26. And then we're asked to find AB. We are going to have to calculate AB. To do that, I am going to draw part of your rectangle. I'm going to draw ABD. AD we were told was 26, AB we were told was 42, and we don't know what AB is. With any right triangle, you can use the Pythagorean theorem. We are going to spend some time discussing Pythagorean theorem in Unit 3. We're just going to do a quick recap. You have done it. It's been a while, so you may have forgotten, but no worries, we'll go back over it. So with the Pythagorean theorem, it says that a squared plus b squared equals c squared. And a and b represent the legs. So the legs in this triangle are x and 26. So x squared plus 26 squared equals c squared represents the hypotenuse. Our hypotenuse is 42 squared. So now I'm going to calculate 26 squared, which is 676. And then I'm going to calculate 42 squared, which is 1,764. And now I'm going to solve this like normal. So I'm going to subtract 676 from both sides, and that's going to leave me with x squared equals 1,088. To get rid of the square, we're going to square root both sides, and at this point you'd use your calculator. Sometimes that number is going to be a perfect square, sometimes it's going to be a decimal. In this case it is a decimal, and we're just going to round it to 32.98. So AB and CD would be 32.98. So those are all the sides that we can find out within that rectangle. So now let's look at the angles. So to make things easier, I am going to erase all of these side lengths that I marked. I am going to mark these pieces congruent. And then let's see, they tell us DAE is 52 degrees. So that is this little angle right here. Because it's a rectangle, we do know that all of the angles are right angles. So don't forget about that. So that means if we know that DAE is 52 degrees, we can find angle BAE because those are complementary. So if I do 90 minus 52, That's going to give me 38, which is going to be the measure of angle BAE. That will also be the measure of angle ACD, because those are alternate interior angles. And angle ACB will be 52 degrees because of alternate interior angles. The other thing that we have is that because the diagonals are congruent and they bisect each other, it actually creates isosceles triangles within this rectangle. And if they're isosceles triangles, then we know their base angles are going to be congruent. So if AE and EB are congruent, then I know DAE and ABE are congruent, so they're both going to be 38 degrees. And likewise, ECD and EDC are going to be 38 degrees. And then you have the two triangles on the side. AED is an isosceles triangle, so that means angle EAD and angle EDA are both going to be 52 degrees. And then on the other side, angle EBC is going to be 52 degrees, as well as ECB. So you have all these, you have two pairs of congruent isosceles triangles. So the only other angles that you could find would be the angles formed in the middle when the diagonals actually intersect. And the way that you could find out those measures is to use your triangle sum theorem. So if I'm looking at either triangle ABE or triangle EDC, it doesn't matter. Remember that the sum of the angles in a triangle is 180 degrees. So to find either one of those angles, whether it's AEB or DEC, I'm going to do 38 plus 38. And then I'm going to subtract that from 180. So 38 and 38 is 76, and 180 minus 76 is 104 degrees. So 104 degrees for these two. And you can do the same thing for the triangles on the side if you want, or because you know those angles are supplementary, you can do 180 minus 104, which is going to give you 76. So now let's make sure we write down all the correct angle measures. We found everything, we just got to record it correctly. So the first thing it asks us to find is ADC. Well, ADC is a right angle, so that's 90 degrees. Then we're asked for DEC. That's that angle that we just found of 104 degrees. ABD is one of those angles we found at the beginning. That is angle that's 38 degrees right here. And then finally, angle BCA would be this angle right here, and that is 52 degrees. I know that's a lot to take in. We found every possible side we could and every possible angle that we could. So let's kind of do something that's a little bit simpler. So in this one, we're looking for the measure of angle JHI. So that would be, JHI would be this angle right here. That angle is going to be congruent to this one that's marked 3x plus 2. But I can't find the measure until I figure out what x is. So the two angles that are given, we do know that those add to equal 90 degrees because it's a rectangle and the angles are 90 degrees. So those angles are complementary. So to find x, I'm going to do 3x plus 2 plus 12x minus 17. And I'm going to set that equal to 90 degrees and I'm going to solve that. So I'm going to start by combining my like terms, 3x plus 12x, that's 15x. And then I'm going to combine my constants. 2 minus 17 is negative 15 equals 90. I'm going to add my constant of 15 to both sides to give me 15x equals 105. And then we're going to divide both sides by 15 to give us x equals 7. Now again, this one did not ask for x, it asked for JHI, and we said JHI is equivalent to GJH. So I'm going to substitute in 7 right here for x, so 3 times 7 plus 2. So that's 21 plus 2, which is 23. So that means that angle JHI is also 23 degrees. Right, and the last rectangle problem we're going to look at, we are told RT is 5x minus 14. RT is that diagonal. We're also told US, which is the other diagonal, is 2x plus 10. And we're looking for VT, so we're looking just for this piece right here. So in order to find VT, I need to know the length of the diagonal, and then I can cut it in half. We do know that the diagonals are congruent in a rectangle, so we are going to set 5x minus 14 equal to 2x plus 10. We're going to move our variable 2x over to the left side and the constant 14 to the right side, giving us 3x equals 24. Divide both sides by 3, and x equals 8. Now that we know what x is, we can substitute it in for either RT or US. It doesn't matter. You should get the same thing. 5 times 8 minus 14 is 40 minus 14, which would be 26. Or if you do 2 times 8 plus 10, that gives you 16 plus 10, which is 26. So either way you look at it, you get that your diagonals are 26. VT is half of the diagonal, so if I cut 26 in half, that's going to be 13. So VT equals 13.